Morning, good afternoon, whatever time of day it is for you, all of you. So I'm going to talk very big picture about an idea that I've came up with in the last year or so. Anyway, so this picture kind of details most of it. I'm calling it Autonomous Solar Barge Propulsion Network. The idea is very large scale. And okay, so a few disclaimers. First of all, is this idea crazy? Yes. The picture on the right-hand side, though, if you look at that, oil platforms, exist in thousands of feet of water, and furthermore drill thousands of feet underground for fossil fuels, and we distribute that everywhere in the world. I mean, that's kind of a crazy idea, but we run the world's economy on that. Can we compete with fossil fuels? The answer is yes. With most carbon-based products, we absolutely can. The exception, as of today, is methane or natural gas. That's going to be tough. And what I'm proposing is, I think, is the way forward. Am I right? Only time will tell. So here's the problem. On the left-hand side, you could see, if you direct your attention to about 1850, you can see a very large exponential growth. That corresponds with the Industrial Revolution and with fossil fuels. It's accepted that everyone knows that we really want to get away from fossil fuels. Solar is a good route forward. If you look on the right-hand side, the question is, well, where's the best place? You'll think, well, maybe Arizona, maybe the Andes Mountains, maybe the Sahara Desert, Australia. But is there a better place? And I kind of alluded to it in the first slide, the ocean. Other issues to note are storage of solar or wind. These are intermittent sources, and storage of them on a large scale is necessary for them to be taken seriously. We'll come back to that. So here's the solution that I'm proposing. So the Sahara Desert, Arizona, Australia, they're great places for solar. We should absolutely have solar panels there. But when we're doing things on a $1 trillion scale or a global scale, is there a better place? Turns out the ocean is actually a better place. So what I'm proposing is essentially a system of barges that follow a seasonal migration pattern, not unlike birds. So they'll essentially skip winter. They will migrate south for the winter and then come back for the summer. My math shows that these barges can outperform any land-based solar installation in the world, because you essentially have a longer day on the average. You combine this electricity with chemicals and seawater and air to create fuels and chemicals necessary for human life. Lastly, because you're already on the ocean, you're now in the most optimal place to transport this globally. And that's the other problem we'll talk about, is transporting it. So about 40% of the world's population lives within 100 kilometers of the ocean. And that's where all the fuels are transported. So if this system is scaled up, it can actually be a way to essentially have an international decentralized energy grid that could have a reservoir of energy that could be 100+ years, which is necessary. Now, what's the market? Well, humans really need three things. We need food and water, we need energy and fuels, and we want stuff. So food, the Haber-Bosch process, essentially you could do that at sea. Fun fact is about half of the nitrogen atoms in your body are a product of the Haber-Bosch process, which currently runs on fossil fuels. Energy and fuels, so voltage, delta T, temperature, heating, cooling, and then transportation. We need fuels for that. All the stuff can be made with seawater and air. And then products, So caustic soda, chlorine gas, oxygen, plastics can be made with everything described. And then the beyond part, fusion. In the process of this, we're essentially filtering out a very large volume of seawater. And in the meantime, we can find the isotopes of deuterium and other isotopes that are necessary for fusion that could maybe help us in the future. Other genetics and biology experiments in the ocean. There's a vast amount of biological diversity that we don't know about there. And then gigaton carbon capture. One thing about that is that to filter out 1 metric ton of CO2, you need about 10 million liters of air, or correction, 1 billion liters of air. You only need 10 million liters of seawater, so it's 2 orders of magnitude less. Concerns, so for these to migrate, you have to put energy in to have them transport. One concern is that energy so large that it's not worth it, and we'll find out. But my math shows that's not true. Essentially, because drag force goes as a square of velocity, you just use a very slow speed, take advantage of ocean currents, and that shouldn't be an issue. Other concern: international water claims. It's hopefully self-explanatory. There's certain parts of the ocean that are like gold mines for this, and who owns them? Well, nobody does right now. And then the other concern is, well, what if we go this way and then solar is not useful anymore? That's where that 100-year reservoir of energy comes into play, or could help. And that's about all I have. And I welcome any questions, comments, concerns, recommendations.